You see my thing is, I don't care about
Qualified. But no,
do is the same.
I'm pretty well known.
Hello and welcome to Maths on the Move, the podcast from plus.maths.org. I'm Marianne Freiberger, and the voices you just heard came from 26 excited mathematicians hard at work at the Maths4DL Learning Hackathon that happened in Cambridge last month. It included students and researchers from universities across the UK and one from Italy. Maths4DL Learning is a research project we've been lucky enough to work with over the last 2 years, which is all about combining theory, so that's mathematics, modeling, data and computation to unlock the next generation of deep learning. That's artificial intelligence to you and me. One of the challenges Maths4DL Learning researchers are working on is to see whether deep learning techniques can help us with the very difficult task of solving differential equations. So these are a type of equations that describe many of the processes in the world around us. One area where differential equations are used is weather forecasting. We know the equations that describe the processes that play an important role in making the weather, but the problem is that these equations are incredibly difficult to solve. Currently, meteorologists use techniques from computational fluid dynamics to find approximate solutions to these equations, but these methods take a crazy amount of computing power. So it would be great if deep learning techniques could come up with alternative ways of solving these equations. And they would do this by learning how to solve them from looking at lots and lots of real-life data about the weather. The Maths4DL Learning research group has a working group on solving differential equations, and it was as part of this working group that the hackathon took place. My colleague Rachel Thomas went along to the hackathon, and she talked to Yolan Lee from University College London, Georg Meyerhofer from the University of Cambridge, as well as a longtime friend of plus.maths.org, Chris Barth from the University of Bath. Rachel started off by asking Georg, who organized the event, what a hackathon is all about.
Oh, that's a very good question. I think it's a very broad term for an event where essentially you get together in groups and you try to solve problems very quickly over a short period of time. And that's what we're trying to do here as well. It's organized through Maths4DL within the Machine Learning for Differential Equations working group. And this is exactly the theme of the hackathon. So we want people to sit down and seriously try to think what the possibilities are and the limitations are when you use machine learning for the solution of differential equations.
So differential equations are equations that, for example, describe how something evolves over time. So, for example, the weather. So you've given the participants data sets and they know roughly what kind of equations they should be dealing with, but they have to, from that data, use machine learning methods to really refine what that equation looks like and what all the coefficients of it are, what the parameters are. And then you can test their equation by seeing what it predicts against what you know it should do.
That's exactly right. And what we're comparing against is data generated with a classical method. In this case, it's an adaptive time-stepping algorithm. And those are the algorithms that are generally used in practice. And so I think the Met Office would use a more sophisticated version of these algorithms, but it's the same kind of theme. And they perform really well. And so it's testing again exactly that kind of.
So we talked to you in an earlier podcast about how machine learning can be used for these, for things like differential equations, which often come from physics. What are you asking the participants to do for their challenges in today's part of the hackathon?
I think it's quite exciting and still themed in the same direction. So on the last podcast, we were talking about physics-informed neural networks. And I think the area of using machine learning for differential equations is actually a bit broader than just that one sub-method. So we'll have two challenges in this hackathon. The first one is exactly to, and we're giving the participants a large degree of freedom to come up with a method that is machine learning based for predicting solutions of differential equations. And that's, I think, kind of the really essential bit that's part of ongoing research where people really think there's a lot of opportunity, but currently very little success in that area in using machine learning tools for weather prediction, structural simulations in airplanes and things like that. So that's the first challenge. But because we suspect that machine learning methods don't really do super well at the moment for these kinds of tasks, the second challenge tomorrow will be for people to come up with a test problem to see what machine learning methods can and cannot do. And the idea is that they will have to design a problem for machine learning methods to test and to highlight an aspect of the method that does or does not work. So that's the idea, yeah.
So it's not that the machine learning methods being used by the participants today are going to be used instead now. There are ways, classical ways, of solving these equations. You mentioned when I talked to you at a previous break that part of today's work is about finding out the best way to judge whether a machine learning method is working well.
Yes, exactly. And so I think from a research perspective, I think people think there is a large amount of opportunity of using machine learning in scientific computing. But I think what's currently missing, and that's something that several people in that domain, more experienced people also feel, is a kind of a lack of baselines, of like objective test problems on which methods can be tested and evaluated. And I think that's extremely important to boost research in that area, because if you come up with a new method, you want to be able to say, well, I outperform what's already been there, and you want to have an objective measure for that. So this is part of that kind of research program, I guess you would say. Yeah.
So maybe from today you'll be a bit further forward to these methods of benchmarking how good machine learning algorithms are.
Yes, so one of the goals, I guess, is to integrate that with the common task framework. That's a set of problems that Nathan Kutz at the University of Washington in Seattle has designed. And I think what we're trying to do in conjunction with that common task framework is to come up with a good set of test problems, but also generate an enthusiasm in the community to actually try and evaluate on those, because I guess it's not so difficult to evaluate your method on your own problems. It's much more effort to try and evaluate it on a set of test data that someone else provides for you, because you have to adapt your method to take in that data. You have to adapt to the setting at hand. So there's a bit of, I guess, reluctance, understandably, in the community to move towards this kind of common framework. And that's maybe one of the goals here today, is to kind of spread the word also and then try and get this enthusiasm going for that. Yeah.
And speaking of enthusiasm, when I was in the room and also when I was at the lunch, it's clear that everyone is very engaged. They look like a lot of younger researchers. Who have you asked to participate in the workshop, in the hackathon today?
I think we've got a really good breadth. I think so. We've got a good mixture of students at the master's level, PhD level, some postdocs, and even some lecturers. So it's really a nice selection of people. And there are one or two participants from industry as well, which is great. And yeah, so this all actually came about through just the Maths4DL community. So that's how we advertised this, and didn't have to advertise too widely to get a lot of interest. So I think this is great. Yeah.
Excellent. Thanks very much.
Thank you.
So a hackathon sounds like quite an exciting way for people to get together and work on difficult problems. Rachel asked Yolaine Lee what it's like to be a participant.
So Yolaine, I was lucky enough to talk to you for a previous podcast, and now you're a participant at the hackathon here today. What has it been like?
I think the morning started out really nicely. I have the luck of meeting quite a few of the people in the room at prior related meetings, so good to see some familiar faces. But there's also plenty of people that I haven't met before, and it turns out during team formation we tried to gather people with a variety of different backgrounds. So the organizers split us into people who were more comfortable with, for example, the numerical side of PDEs, as well as people who were more comfortable with machine learning methods in general. And the group that I ended up with, I have not met any of them. So just first and foremost, it was really nice to just talk to new people. And even in undergrad, I really enjoyed hackathons for the same reason. You get people in the same room who are interested in doing something with some kind of problem. And so you have like a mutual topic to talk about. In addition to also learning about their different backgrounds has helped us form the team and form a direction of investigation, I suppose. That was pretty unique to what I had done before previously.
So the types of equations you were working on in today's challenge, we have classical ways that are already working well. But the idea isn't necessarily that the techniques you'll come up with today are better, but it means you can check your answers, I suppose. And you can also, Georg was saying, it's about kind of providing like a benchmarking idea of how well your method does against the classical solver or against other machine learning methods.
Yeah. To put it very plainly, if we have a result today that even nears the performance of a classical solver, we also have a paper to write. It's maybe it sounds a bit pessimistic, but it's very unlikely that we're going to get to the accuracy of any kind of something that's comparable to a classical method. At the same time, though, the point of it was that we want to tackle these more complex problems because I think that's also where neural networks have more potential to be actually used.
The places that we don't have classical solvers that work well for.
Yes, yeah.
And what's the experience been like? I went in and everyone is working very hard and having very in-depth discussions. Is it difficult? Is it fun? Is it confusing? What's it like sitting down with people you've only just met and working on a problem like this?
Probably all of the above. As I said before, it's really enjoyable to be able to talk to people who either haven't actually touched similar problems, and so they come in with somehow a blank slate, which is really nice. My PhD is more focused on PDEs and neural networks itself, so I'm perhaps more used to seeing certain types of, or like lines of thinking already. But the people who come in with different backgrounds have more out-of-the-box ideas, which make me excited. It is also a difficult problem. These are not the most complex PDEs that you could find. There are plenty more that are much wilder beasts. But that being said, they're still finicky to work with. Actually, I was just working on a problem where we want to be able to generate more data. But as I've just mentioned, these are non-trivial PDEs, and so generating data itself takes time. And time is not something you really have in a hackathon.
You've got, what, a couple more hours?
Yeah, I guess until 9 or so. Or 8, sorry, yeah. But that means even trying to write a faster solver is well, that's the hard work of mathematicians for probably the last couple centuries. Yeah. So
it's quite a challenge to do that under a tight deadline. And is the experience of having only a few hours to work on a problem with people you've only just met in one day, is that how does that compare to your normal experience as a researcher working on these kinds of things? Is this quite different? Does it feel quite unusual? Does the pressure make you think differently?
First of all, I think it's really refreshing. My day-to-day work is stuff that I've been thinking about at least for, ongoing for some amount of time. And this, because it's only a day, I feel like I can completely not think about my work and only think about this topic. And same goes for the rest of my team. And so in all honesty, we're all quite productive, I would say. The type of work that we're doing is very similar to what I would do in my projects, in my day-to-day work. And I would guess very similar for the rest of my teammates. But just condensed somehow, because all of us are working solely on a single project, whereas perhaps in your day-to-day work you might be split across a number of different responsibilities.
And it's nice to be part of a team. What's that like?
Yeah. The upsides and downsides of digital communications means that sometimes or very often I suppose, you collaborate with people who are not directly in the room with you. And so now having everybody quite literally on one table where I can bug anyone at any point, again, means that we're faster in some way. I think I also got pretty lucky with my team. We're all very talkative, and that means we spent a long time talking through how we want to approach the problem, and now we're getting a decent amount of work done based on our previous discussions. So, again, having good communication, so, great teammates as well, but also being in the same physical space means that we can ideate a lot faster.
Yeah. With enough tea and coffee and biscuits.
Exactly. I think the biscuits are out now, I guess.
I think they are, so I should let you get back and get a biscuit.
It's my pleasure, though.
Thank you.
Of course.
Rachel spoke to Yolan and to Georg on the first day of the hackathon, but she was also keen to know how the second day went. So she caught up with Georg again and with Chris Budd over Zoom after the event.
So we talked to you both at the Maths4DL hackathon a couple of months ago here at Cambridge, which took place over 2 days. How did it go? Georg, were there any particular aspects that stood out to you in your memory?
I think it went really well. I mean, I was super impressed by the enthusiasm with which people were working on the challenges. I think that's the big thing that stood out for me was that somehow we had prior meetings, and I felt that now that we introduced a competitive element into this meeting, there was real engagement and real enthusiasm for people to directly work on the challenges during the hackathon, even beyond. And we received a significant amount of emails afterwards of people wanting to continue working in this area and maybe engage further in events that we might organize in the future. So I think overall it went really well. Yeah, I don't know, Chris, how you feel about it. It's similar for you.
Yeah. Well, I think it went very well indeed. And we had to look at the kind of solutions that the teams came up with. And some of them were very, very imaginative. Well, more than imaginative. They'd actually made big inroads into very difficult problems. And to be able to do that basically in one day was really remarkable.
And the first challenge on that first day of the hackathon was to see if the teams could come up with a machine learning method for solving some particular differential equations that you'd set them. How did that go, Georg?
Yes, so this went surprisingly well actually, because the teams really only had half a day to work on this essentially and to come up with a good solution methodology. And I say this went really well because those challenges, they had numerical scores, and we are involved in a wider consortium led by Professor Nathan Kutz, who is trying to come up with a common task framework that benchmarks machine learning techniques more broadly for solving differential equations. And this benchmarking framework is very similar to the challenges that we had on that first day. And I know how state-of-the-art machine learning techniques perform numerically on those evaluations. And I think the scores that the teams were able to achieve in the one day on the hackathon were really on par with the state-of-the-art, and sometimes even a little bit better for the targeted challenges that we had. So this was impressive to see. I think this was something that we may not have expected beforehand. And yeah, just a sign that if you really put your mind to it, and if you have a concrete problem at hand, you can do something amazing in just a day. So that's great.
That's really impressive, that in just one day they could produce methods that performed, better than some of the other known methods. And that idea of benchmarking, that was an important part of the second challenge, which was on the second day, about coming up with test problems that could be used for this sort of benchmarking idea of machine learning methods. Chris, why is it useful to have this way of benchmarking the performance of machine learning methods?
So it's important to have a set of kind of problems everyone can try their methods against, so you can really test how well your method performs against other methods. But one of my concerns is that in the literature, there's been a kind of standard set of test problems and everyone's calibrating against those. So you might be developing very good methods just for those benchmarks. And so we felt it'd be a good challenge to come up with some new benchmarks, which would allow us to kind of further test models in better ways on problems which might, let us say, be more relevant to some of the problems you might meet in applications.
And Georg, how did that second challenge go?
I think, again, really well. So the second challenge was a little bit more open-ended, and it's quite challenging to come up with a thorough kind of benchmarking framework on just a single day. So that definitely meant that that perhaps it was less clearly defined as the first challenge, but the teams came up with really exciting ideas. Obviously, the final product was for them to give a presentation and to provide us with some actual concrete files that we can use in the future. And I think that the leading two teams came up with really exciting, so all teams had really exciting ideas, but the leading two ones are particularly useful. So one of them was to test machine learning frameworks on limited data. And that's an example that is really relevant to applications and actually feeds directly into the common task framework in this consortium that we're developing. So the idea is that instead of simulating with full information, you might have just noisy data, so some sort of or perhaps limited observations from just individual sensors at specific locations. And the idea of that test is to see if you are able to reconstruct, or how much you reconstruct of the actual physical behavior of that system based on that data. And the leading team, the winning team, actually had an idea of trying to use machine learning techniques or test machine learning techniques on how well they perform in terms of downstream tasks. So what that means is you might use a machine learning method to provide a simulation that is then used for example, design optimization or control of another system. And this is again a really incredibly relevant application, and quite exciting that the teams came up with that. And I think what it will lead to is that we've already discussed with Chris and the wider working group that those are topics that we want to pursue further, that we want to investigate and add and perhaps add into this common task framework as a challenge for the future. But either way, it's an incredibly relevant testing problem that we definitely need to explore further when we want to say whether a machine learning method is good or not good for simulation tasks.
It's impressive that, I know it was an intense couple of days, but in such a short period of time, bringing people together in the right environment, they can make such significant contributions to furthering the ideas. And I believe there's a paper has come out of some of this work that you're taking to a conference next month.
Yes, we've been delighted. So this is a paper in this wider framework of scientific machine learning, and it's jointly with several people who are involved with the hackathon, including Chris. We've been working on adaptive meshing for finite element methods, and I guess in some way this fits into this idea of using machine learning to help with a downstream task, and a downstream task in this case is finite element simulations. So we were very happy that our graph neural network approach to this problem was just spotlighted at ICML, which is one of the leading conferences in the field. And we're hoping that this is the basis for a wider kind of program of research in this broad area of scientific machine learning in our Maths4DL team and more broadly at the universities involved.
And Chris, do you think this approach of using hackathons is something that Maths4DL might use again?
Very much so. The idea of kind of bringing teams together to work together on solving problems has been very effectively used in say applied maths areas, and now bringing it in this context, scientific machine learning is proving equally successful. And we are planning to have another hackathon in the autumn in a similar kind of format, though of course we'll have different challenges this time round. And I'm very confident that it will be as successful as the last one.
That's great. Thank you very much.
Thank you.
Thank you.
That's it for this edition of Maths on the Move. We will keep up with Georg, Jolan and Chris and other researchers from Maths4DL to keep reporting on their work. And we will put links to other relevant articles and podcasts into the show notes. If you like this podcast, then please recommend us to a friend or rate and review us wherever you're listening to the podcast. It will really help others find it. Thanks for listening and bye for now.
You see, my thing is, I don't care
Qualified.
I would be upset.
That's pretty well known.